Hi, welcome to Lesson 16b, Increasing and Decreasing Functions. We need to determine where a variety of functions will increase and decrease. So in this example, we're going to consider the function f of x equals negative x squared plus 4x minus 7 all over x minus 1. What we want to do is show, for part A, that the gradient function equals negative x plus 1 times x minus 3 all over x minus 1 squared. And then we're going to draw its sign diagram. Okay, so if we're in charge of showing that this derivative is so, I guess we should take the derivative. So for part A, I will just begin. So we know that this is the function f of x, so then f prime of x, I will be using the quotient rule here. So the derivative of the top is negative 2x plus 4. And then we multiply that by the bottom, which is x minus 1. And then we subtract the derivative of the bottom, which is 1. And we multiply that by the top. And we put that all over the bottom squared. Now it's just a matter of simplifying this a little bit. Now, in order to draw a good sign diagram and find out where there are x and y intercepts, or sorry, not y intercepts, but x intercepts and vertical asymptotes, it's probably a good idea to simplify this as much as possible, and that's why we're aiming to show that the derivative is as is asked here in part A. So we can take a look at this. We can try to do some factoring, but there's not really much to factor out here at all. So in a case like this, when you don't see anything that can really be factored out easily, I think the best thing to do would be just to expand out these two binomials and then simplify the numerator and then see if you can factor it. Okay, so we now have negative 2x squared as I expand this out into the second bracket, plus 2x plus 4x minus 4. And then we've got a negative times, so I'm just going to multiply this negative in here, so I end up getting a plus x squared minus 4x plus 7. And that is still all over x minus 1 all squared. Now I'll just simplify the numerator here by taking the combining the like terms. So I've got negative x squared. That takes care of the negative 2x squared and the positive x squared. And then I've got plus 2x, because that takes care of this positive 4x and negative 4x. And then I've got plus 3, which then takes care of this negative 4 and plus 7. Okay, so now I'll still have that over x minus 1 all squared. I'll factor out the negative 1 from the numerator because I tend to like the look of a polynomial expression with no negative in front of the x squared term. And then so I see this, and then I can quickly do a little bit of factoring. So I've got x minus 3 and x plus 1 all over x minus 1 squared. And then I'll look to see if there's anything I can simplify from the numerator and denominator, but there are no common factors in the numerator and denominator, so that is the way I have to leave that. So the derivative function, or the gradient function, is f prime of x equals negative x minus 3 times x plus 1 all over x minus 1 squared. And if I look up here, that is exactly what I was meant to show. Okay, so we've got the derivative function. We're supposed to draw a sign diagram. And we need to take into account all the different areas of this function where there are horizontal asymptotes and where perhaps there are vertical asymptotes, or not horizontal asymptotes, but horizontal tangents and vertical asymptotes. So I can take a look here and I can see that this gradient function is undefined when x minus 1 all squared equals 0. And that will actually give us a vertical asymptote. And so when x minus 1 all squared equals 0, that is when x equals 1. Now, in terms of horizontal tangents will occur when the derivative function, the gradient function, equals 0. So when this equals 0, then if we multiply both sides by the denominator, then we see that 0 equals negative x minus 3 times x plus 1. Therefore, x minus 3 could equal 0, or x plus 1 could equal 0. Therefore, sorry, that should be 0 here. Therefore, x equals 3, or x equals negative 1. So we've got the two places where there would be horizontal tangents, and we've got the place where there's a vertical asymptote. So we can put all of these things together on the sign diagram. So I'll see if I can draw a straight line here. That would be kind of nice. There we go. And so we've got a couple places where we have horizontal asymptotes, and we've got sorry, I kept saying that again, where we've got horizontal tangents, and here's a vertical asymptote here. So now what I'll do is we've got negative 1 here at one spot where there is a horizontal tangent. X equals 1 is a vertical asymptote, and x equals 3 at another horizontal tangent. So now if we just choose values in these intervals and substitute them into the derivative function, we can find where the graph is increasing or decreasing. So I'll choose a larger value than 3 and substitute it in here. And so let's say 5. That'll leave the denominator positive. That will leave this positive. That'll leave this all positive. But we're multiplying by a negative there. So it's a negative, which means that this, in this interval, the function is decreasing. Then I'll choose a value between 1 and 3. So say 2. Keep it easy for myself. So 2 substituted in for this bracket will leave that positive. 2 minus 1, and I'll again square, that'll leave that positive. This bracket will be negative, but then we're multiplying by a negative, which means that in this interval it's positive, which means that the graph is going to be increasing, or the function is going to be increasing. Then I choose a value between negative 1 and 1, so say 0. 0 in here, positive, that's squared, then positive. That's going to be negative, but negative times a negative. So that leaves that as a positive again. So the function is going to be increasing again there. And then we choose some value less than negative 1, so say negative 5 or so. That'll be negative there. That'll still be positive. That'll be negative, but negative times a negative times a negative gives us a negative. Therefore, the graph is decreasing on that interval. And now what we need to do for part B is find the intervals where y equals fx is increasing or decreasing. So by looking at the sign diagram, so now for part B, I can say that f of x is increasing on a couple intervals. One, when -1 is less than or equal to x, less than or equal to 1. Sorry, that should be less than 1 because there's a vertical asymptote there. And x cannot actually be, sorry, as I mess this up even more, there we go. And it's also increasing when 1 is less than x, less than or equal to 3. And all of this, ditto ditto, decreasing. So the function is decreasing when x is less than or equal to -1 or x is greater than or equal to 3. Okay, so that is the end of that example. Please take a look at a couple of these questions at home and then come in and do the rest in class. So thank you very much for watching, and we'll see you in class.